Section 9.6, using the quadratic formula to solve quadratic equations. So far we've already talked about two types of quadratic equations that we can solve, those that factor and those that are perfect squares. So let's solve each of these just for a reminder on the process. Equations that factor. The first equation factors, you can take your 10 and break it into two things that multiply to 10 and add to negative 7. Since it's a positive 10 and a negative 7, I'm going to need two negatives. So we're going to use negative 5 and negative 2 to get negative 7. This factors into x minus 5 times x minus 2 equals 0. And then to continue solving, we're going to take each part and set it equal to 0. So I have x minus 5 equals 0 and x minus 7 equals 0. If you add 5 to both sides, we get x equals 5 for one of the solutions. And if you add 7 to both sides, x equals 7 for the other solution. Just a quick reminder on factoring to solve, and then let's look at using the square property to solve. If you have a quantity squared, you can take the square root of both sides. So that'll give you x plus 3 equals plus or minus the square root of 8. So x plus 3 equals plus and minus the square root of 8 needs to be simplified. That can be written as the square root of 4 times the square root of 2. You know what the square root of 4 is, so x plus 3 equals plus or minus 2 times the square root of 2. Now to get x by itself, you need to subtract 3 from both sides. So you have x equals negative 3 plus or minus 2 times the square root of 2. Those answers separately are negative 3 plus 2 square root of 2 and negative 3 minus 2 square root of 2. But does that cover all the possibilities? No. Let's think about x squared plus 7x plus 4 equals 0. Can you factor it? No. The only things that go into 4 are 4 and 1 or 2 and 2. 4 plus 1 adds to 5, 2 plus 2 adds to 4. There's no way to get a 7. Can you get it in the form of something squared equals a number? No. My x squared, if I were to get that by itself, there would be some x's on the other side, and I'm not going to be able to use the square root property for that. So I need a third method for solving some of these quadratic equations. This method is the quadratic formula, and it is an equation that you should memorize. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where a, b, and c are the coefficients of x squared, x, and the constant respectively. Let's use this formula in an example. And we're going to solve the equation x squared plus 2x minus 24, both by using the quadratic formula and by factoring. So in the quadratic formula, the value of a is the coefficient of x squared, so that's 1. The value of b is the coefficient of x, so that's 2. And the value of c is the constant, so that's negative 24. The equation does need to be equal to 0 before you can use the quadratic formula. Okay, so into the formula, x equals negative b, so b is 2, so that's going to be negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is negative 24, all divided by 2 times a, which is 1. Let's simplify. I've got negative 2 plus or minus the square root of 4 minus 4 times 1 times negative 24. 4 times 24 is 96. The negative and the negative are going to make that a positive, so I'm going to have plus 96 right here, all divided by 2. So that's negative 2 plus or minus the square root of 100 over 2. And I know what the square root of 100 is, so I have negative 2 plus or minus 10 over 2. You can add those two numbers. They are like, so we're going to split this into two answers. One of them is negative 2 plus 10 over 2, and the other one is negative 2 minus 10 over 2. Let's simplify each one. Negative 2 plus 10 is 8 over 2 is 4. And negative 2 minus 10 is negative 12 over 2 is negative 6. So the two answers are 4 and negative 6. Let's go back and look at that same equation, but let's look at it using factoring. This equation is x squared plus 2x minus 24 equals 0. And if I want to factor that, I'm going to use my negative 24. I'm going to break it into two numbers that are going to add or subtract to 2. And I know I need one positive and one negative with a larger positive to get a 2 in the middle. Let's try a couple things that go into 24. I know that 24 is 8 and 3. 8 minus 3 is 5, so that doesn't work. It gives us a 5 instead of a 2. I know that 24 is 12 and 2. That gives us a 10. Doesn't work either. And I know that it's 6 and 4. 6 minus 4 gives us 2, so this pair works. This factors into x plus 6, and x minus 4 equals 0. So if you solve each of these, x plus 6 equals 0, and x minus 4 equals 0. Subtracting 6 from both sides gives you x equals negative 6, and adding 4 to both sides gives you x equals positive 4. So these are my two solutions. Those are the same two solutions we got using the quadratic formula, but they were much easier to get using the method of factoring. So just because the quadratic formula works doesn't necessarily mean it's the best method. You want to check the other two first. You want to check factoring and the square root method. For both factoring and the quadratic formula, you must set the equation equal to 0. Always try factoring first because it is often easier. Alright, so we're going to solve these using the quadratic formula because we want to practice the quadratic formula. Some of them might be factorable, so on your own you might want to check that out and see if you can factor them as an easier method for solving. So now the first step I need to do is get the equation equal to 0. So we're going to add 2 to both sides to get this equation equal to 0. X squared plus 5x plus 2 equals 0. Now we have our value of a is 1, our value of b is 5, and our value of c is 2. So into the quadratic formula they go. X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Okay. So negative 5 plus or minus the square root of that's 25 minus 8, and 25 minus 8 is 17 over 2 times 1 is 2. The square root of 17 cannot be simplified, so this is done. There's nothing I can do with the square root of 17. I can't add 5 to it, so I have this fully simplified. Okay, part B. Let's get everything to the same side. It's equal to 0. So we're going to subtract the 4x off and subtract the 1 off. We'll have 2x squared minus 4x minus 1 equals 0. So a is 2, b is negative 4, and c is negative 1. The quadratic formula is negative b, so negative negative 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 2, times c, which is negative 1, over 2a, which is 2. Okay, so negative 4 is positive 4, plus or minus the square root of negative 4 squared is 16, minus, but I've got another negative here, so two negatives are going to make this positive 8 over 4. So I have x equals 4 plus or minus the square root of 24 over 4. The square root of 24 can be broken down into the square root of 4 and the square root of 6. 4 is a perfect square, so this is 4 plus or minus 2 times the square root of 6 over 4. And now we're going to divide everything by 2 to simplify. So it's going to become a 2, a 1, and a 2. That's the same thing as factoring out the 2 and then reducing. So my final answer here is 2 plus or minus the square root of 6 over 2. And again, that is two separate answers, 2 plus the square root of 6 over 2, and 2 minus the square root of 6 over 2. Part C, let's subtract the 1/2 over to get this equal to 0. That's going to be 5/6 x squared plus 2/3 x minus 1/2 equals 0. The a is 5/6, the b is 2/3, and the c is negative 1/2. But I really am not looking forward to plugging in those fractions into the quadratic formula. So since this is an equation, I can multiply everything by the common denominator to simplify it. Let's multiply everything by 6. This will become 5x squared. 2/3 times 6 is 4x, and 1/2 times 6 is minus 3 equals 0. These numbers, 5, 3, and 4, are going to be a lot easier to plug into the quadratic formula. So we're going to use a equals 5, b equals 4, and c equals negative 3. Okay, so in our quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's negative 4 plus or minus the square root of 16 plus 60 over 10. And 16 plus 60 is 76. So I'm going to have negative 4 plus or minus the square root of 76 over 10. 76 can be divided by 4, which is a perfect square. So we're going to simplify this to negative 4 plus or minus the square root of 4 times the square root of 19 over 10. So I have negative 4 plus or minus 2 square root of 19 over 10. And then I need to reduce by dividing everything by 2. So it's going to give me 2, 1, and 5. So let's squeak my final answer in here. Negative 2 plus or minus the square root of 19 all over 5 is my final answer. I'll try to write a little bit smaller in the next one. We need to get this equal to 0, so we need to first undistribute so we can combine like terms, and then we'll try solving with the quadratic formula. 2x squared plus x minus 6x minus 3 equals negative 18. So I have 2x squared minus 5x, and we're going to add 18 to both sides to get this equal to 0. So negative 3 plus 18 is going to be plus 15. So in this equation, our a is 2, our b is negative 5, and our c is 15. So we have x equals negative b, so negative negative 5, plus or minus the square root of b squared. Negative 5 squared is 25, minus 4 times a times c, all over 2 times a. Negative negative 5 is positive 5, plus or minus the square root of 25 minus 4 times 2 times 15 is 120 over 4. So I have 5 plus or minus the square root of negative 95 over 4. There are no perfect squares that go into 95, so I can't pull out a 5 or anything. It's not a perfect square. But I can pull out the I from the negative 95. So this will be 5 plus or minus I times the square root of positive 95 all over 4. So this equation has two complex solutions. Alright, so we have three methods. Factoring. Factoring works if you can factor the equation. Square root. The square root method works if the equation can be written as perfect square equals a number. And the quadratic formula that works every time. The reason that we don't use the quadratic formula every time is that it's not always the easiest method. So on the next page, I'm going to solve using the most efficient method. In example A, I want to solve this. I've got my perfect square by itself. There are no other x's, so I'm going to use the square root method. So this one's going to be x equals plus or minus the square root of negative 2d plus 35. Now I also want to do this one. This equation might here be a typo. So what if we change it to x squared equals negative 2x plus 35? That probably should be an x right there. If I solve it this way, I probably want to add this over to get it equal to 0 because this looks like it could be factorable. So if I add over the negative 2x, it'll be x squared plus 2x, then subtract over the 35. I'll have minus 35 equals 0. Let's check to see if this is factorable. What goes into negative 35? 5 and 7 do. If we want the 2 to be positive, the 7 needs to be positive and the 5 negative. This factors into x plus 7 times x minus 5 equals 0. Set each of these equal to 0, x plus 7 equals 0, and x minus 5 equals 0. Subtract 7 from both sides. The first solution is x equals negative 7. Add 5 to both sides. The next solution is x equals positive 5. In part B, the only variable is inside of a perfect square, so we're going to use the square root method. Add your 1 over. That's 2 times x minus 2 squared equals 16. Divide both sides by 2. I get my perfect square, x minus 2 squared equal to 8. Now take the square root of both sides. X minus 2 equals, when I take the square root, I get plus or minus the square root of 8. Now I need to simplify that square root of 8. That's plus or minus the square root of 4 times the square root of 2. So x minus 2 equals plus or minus the square root of 4 is 2. So I have 2 square root of 2. Now add your 2 over. And we're going to have x equals 2 plus or minus 2 square root of 2. Okay, part C. So this is not factorable because all things that go into 3 are 3 and 1. 3 and 1 add to 4. They don't add to 1. So since it's not factorable and I don't have a perfect square only because there's another x here, the only method I can choose is the quadratic formula. So a is 1, b is 1, and c is 3 since it's already set equal to 0. And we're going to get x equals negative b, negative 1, plus or minus the square root of 1 squared, which is 1, minus 4 times a, which is 1, times c, which is 3, over 2 times a. So that gives us negative 1 plus or minus the square root of 1 minus 12 over 2. So negative 1 plus or minus the square root of negative 11 over 2. So that's negative 1 plus or minus I times the square root of 11 over 2. Okay? Let's look at part D. This one might be factorable. Let's try. If I can factor, it's going to be easier than using the quadratic formula. 4 times negative 2 is negative 8. 4 times 2, but 4 minus 2 is 2, and 8 times 1, and 8 minus 1 is 7. So this one doesn't factor. Okay, so since it doesn't factor, we need to use the quadratic formula. So a equals 4, b equals 3, and c equals negative 2. So we have x equals negative 3 plus or minus the square root of 3 squared is 9 minus 4 times a, which is 4, times c, which is negative 2, all divided by 2 times a, 4. So we've got negative 3 plus or minus the square root of 9, and then 4 times 4 times 2 is 32, 2 negatives, so it's going to be plus 32 over 8. So I've got negative 3 plus or minus the square root of 41 over 8. The square root of 41 cannot be simplified, so that's my final answers. In example 4, the amount of electricity flowing through a surface is the current, and it's measured in amps. The current through a particular wire can be modeled by the equation I of t equals 2t squared minus 6t plus 7. Find when I of t equals 10. So we're going to plug 10 in for I of t. 10 equals 2t squared minus 6t plus 7. I want to get this equal to 0, so we're going to subtract 10 from both sides. So that's 0 equals 2t squared minus 6t minus 3. Now we're going to use the quadratic formula to solve. Our a is 2, our b is negative 6, and our c is negative 3. So we have t equals negative 6 plus or minus the square root of negative 6 squared, that's 36, minus 4 times 2 times negative 3 over 2 times 2. So I've got 6 plus or minus the square root of 36 plus 24 over 4. 6 plus or minus the square root of 60 over 4. And this can be separated into 6 plus or minus the square root of 4 times the square root of 15 over 4. So 6 plus or minus 2 square root of 15 over 4, which I can reduce by dividing by 2. So my answer is going to be 3 plus or minus the square root of 15 over 2. Now let's look back at the original problem. I want to find t, how many seconds it has been until the current is 10 amps. So I want to give my result in 2 decimal places, so we're going to want to round these values. Grab your calculator. Make sure you type parentheses around the numerator. We're going to have 3 plus the square root of 15 over 2. And if you hit second and enter, it'll bring that back up, so you can do the same thing with just changing the addition to a subtraction sign and then just hit enter again. So there are 2 times when the current reaches 10 amps. After 3.44 seconds and after negative 0.44 seconds. Part B, I want to verify the answer using our calculator. So we're going to need to type the equation into the y equals menu. Recall that the equation that we were trying to solve was 2x squared minus 6x plus 7 equals 10. So in my calculator, I'm going to type the left-hand side and the right-hand side into the y equals menu. So pull up your calculator. You can see I've already entered the right-hand side. In my second equation, I'm going to enter 10. Now let's graph. I'm going to hit zoom standard to make sure that I'm in a standard window when I graph. So option 6. First graph that should be showing up is the graph of 2x squared minus 6x plus 7. And then y equals 10 is right there across the top. I'm going to make my window just a little bit higher so I can see the intersection a little more clear. Right now the y maximum was 10, so I could barely see that graph. Let me go ahead and make that 15. Let's look at the graph one more time. Right, so we can see 2 intersection points. One of them does have a negative t value, and the other one has a positive value, so let's check those by finding the intersection of these 2 curves. Second, calculate, option 5 for intersect. First curve, second curve, just hit enter, and then go over closer to 1. The first one, hopefully it's about negative 0.44 if you round that. That looks like what we had before. And second, calculate, intersection, option 5. First curve, second curve. And I need to make sure that my cursor moves closer to the second intersection so I can find that one with my guess this time. The second one, 3.44, that also matches what we found by hand. Right, and that's the end of this section.